Hello everyone, welcome to today's class. In this lecture we'll talk about inverse inverse trigonometry, the full name. Okay, so basically we have to deal with one particular problem, that is if your sine x is 1 by 2, what's my x? Okay, we have seen this in trigonometric equations also, that this has principal solution, then you have general solutions. General solutions are infinite because sine x is 1 by 2, first of all for pi by 6, then in second quadrant that's pi minus pi by 6, 5 pi by 6, then you can keep adding 2 pi in it. Okay, so 2 pi plus pi by 6, because of the rotation effect, there is no effect of rotation. 2 pi plus 5 pi by 6, and this can have infinite answers. That's why we generated general solutions, n pi plus minus 1 raised to power n and one principal solution, and n belongs to z. Okay, that was regarding trigonometric equations. Now what we can do here is we can directly say x is sine inverse 1 by 2, means we take sine to the other side, it becomes sine inverse. That's the representation. Okay, the meaning of this is that sine x is 1 by 2. For what value of x, that sine will be 1 by 2, but we have to deal directly with this sine inverse. Okay, and don't confuse this. This is not equal to 1 upon sine 1 by 2. Okay, this is not power minus 1. Okay, don't try to think of this as a power. So this is wrong, absolutely wrong. Okay, now let's see what we have to solve. Now the problem is still the same, that what should I write? X is okay, the representation has changed, but what should I write now? X, pi by 6, 5 pi by 6, or which particular one? So for that, what we have to do is we have to define some principal range. Okay, so for sine inverse x, will give the answer from minus pi by 2 to pi by 2. Okay, for cos inverse x, will give answer from 0 to pi. Okay, this is something that we have to constrain in order to give one particular solution. So this is pretty much defined, that we will give the answer of sine inverse x from minus pi by 2 pi by 2, cos inverse x 0 to pi, and more importantly tan inverse x from minus pi by 2 to pi by 2. Okay, open interval. I'll not talk about specifically with sec, cosec, cot. Okay, there are principal range for that also. Okay, but they are pretty much same idea like this. Okay, they have pretty much same idea. In fact, let's write it. Let me write it anyway. Rather than writing like this, what I'll do is I'll categorize this also. Okay, all right. Okay, one second. Yes, so for cos inverse I'll write it here. Okay, cosec inverse also I'll categorize here, because sine and cosec, they pretty much behave same. Cosec inverse x again will give the answer from minus pi by 2 to pi by 2. Is that will never give 0 as an answer. Okay. Reason, because in that cosec is never 0. Okay, because cosec 0 means 1 by sine 0, sine 0 means 0, so basically 1 upon 0 is infinite, so that's why you cannot have that. Okay, cosec inverse x. Okay, so for this general idea, again cosec I've given, cos I've given, and then sec will behave pretty much same as this, 0 to pi Okay, except you cannot have pi by 2 as your answer. Same reason, cos pi by 2 is 0. So sec pi by 2 is infinity, which is not defined. That's why you cannot have this as your answer. And finally your cot inverse 6. You'll give the answer in 0 to pi. Okay. Yeah. All right. So we will be giving the answer of sine inverse from minus pi by 2 pi by 2, cosec minus pi by 2 pi by 2, tan also from minus pi by 2 pi by 2. Apart from that, cosec, sec, cot inverse will give the answer from 0 to pi. You don't have to specifically remember this unless and until it is asked directly. It's just that you have to learn these two categories: sine, cosec, tan, these inverse in 1, and cosec, sec, cot, these inverse in 1. Okay. All right. Let's see questions now. How to solve them. I'll put the question myself once again. Then we'll deal with those questions. Find principal value. Okay, principal value means you have to give your answer in that particular range that we just discussed. Sine inverse 1 by 2. Then let's deal with positive first. Cos inverse 1 by 2. Tan inverse 1. Okay. Then we'll deal with negative values. Okay. Sine inverse minus 1 by 2. Cos inverse minus 1 by 2. Tan inverse minus 1. Okay. Okay. First part. For sine inverse 1 by 2. Okay. So we have to give answer in minus pi by 2 pi by 2. When is sine 1 by 2? So this is very obvious. Pi by 6. 30 degree basically. Na? Convert that into radians. You have to always give your answer in radian. Second part again. Cos is 1 by 2 in the first quadrant. Okay. So we have to give the value of theta for which cos is 1 by 2. That's pi by 3 or 60 degree. Okay. Third part. Tan inverse is 1. Means we have to get the value of theta for which tan is 1. That's pi by 4. Okay. So for positive value, we don't have any problem because we'll give the answer in first quadrant. Okay. The problem comes with the negative. How to deal with negative? Now, dealing with negative of sine inverse and tan inverse is very easy because we have to give the answer in minus pi by 2 pi by 2. Means negative values are allowed now. So what we can do is we can take this negative outside. We can take this negative outside. So I can rewrite the question. Sine inverse minus 1 by 2 is minus sine inverse 1 by 2. Negative can come outside, and sine inverse 1 by 2 we have already solved. That's minus pi by 6. Next, same thing. Let's solve tan first. Tan inverse minus 1. You can take negative outside in tan inverse also. Minus tan inverse 1. Now what is tan inverse 1? Pi by 4. So minus pi by 4 it will become. It's just that with cos inverse you cannot directly take negative outside. Okay. Because even if we suppose we take it outside and we give the answer as, let's say, minus pi by 3. First of all, this is in fourth quadrant. Fourth quadrant cos is positive. Second problem, we have to give the answer in 0 to pi. Okay. So for negative value of cos inverse, you cannot directly take negative outside. What you can do is subtracted from pi minus cos inverse of positive value. Okay, this is, remember, for anything that is having a principal range in 0 to pi. Whenever you get the negative value, okay, whenever you get the negative value, what you have to do? Pi minus cos inverse of the positive, okay, or cot inverse of positive, or sec inverse of positive. Okay, so pi minus cos inverse 1 by 2, we know, pi by 3. So what's the answer? 2 pi by 3. See, this is from 0 to pi. Okay, so you have to be careful regarding these three: cos inverse, sec inverse, and cot inverse, because for these three the principal range is 0 to pi, so you cannot take directly negative outside. So what you have to do is do the pi minus cos inverse, although this is properties, but right now I'm teaching you in general. Okay, because if I keep adding properties, it'll confuse you a lot. Okay, so we are going for a general approach, how to solve these kinds of values directly. Okay, so sine inverse, tan inverse, you can take it outside. Cos inverse, you have to do pi minus. Now let's look at the question that was there. Okay, I think that we just did this one, sine inverse negative. Okay, so cos inverse root 3 by 2, this will do. Cos is root 3 by 2 for 30 degree, that's pi by 6. Cosec inverse 2. So if you get confused regarding this, try to you can use this also, that now I'll add some property here, that sec inverse x is equal to cos inverse 1 by x. It's pretty much same as sec theta was 1 upon cos theta, na? Same thing. You have to reciprocal the inside value. Same with cosec inverse. Cosec inverse 1 x is sine inverse 1 by x, and cot inverse x is tan inverse 1 by x. Okay, done. Now let's see. For this, try to think when cosec is 2, or you can rewrite this as sine inverse 1 by 2. Okay, what is sine inverse 1 by 2? Again, that's pi by 6. So pretty obvious. Okay, let's look at the few other questions and get comfortable with the principal value, because these questions will be very direct and very straightforward. Okay, now tan inverse negative. So in the case of tan inverse, negative can come outside, so that becomes negative tan inverse root 3. So that is minus tan inverse root 3 is when is tan root 3? For 60 degree, so that is pi by 3. Next, cos inverse, sorry. So for cos inverse of negative, what do we have to do? We have to do pi minus cos inverse of 1 by 2. So pi minus 1 by 2, I think we just did this, na? Cos is 1 by 2 when cos 30, no, cos 60. So pi by 3, so that is 2 pi by 3. Same thing, tan inverse again negative, take it outside. So minus tan inverse 1. So negative tan inverse 1 is, when is tan theta 1? For 45 degree, or pi by 4. Okay. Let's look at few other questions. All right. Sec inverse 2 by root 3. So positive value is there, so no need to worry. So we can write this cos inverse root 3 by 2. Reciprocal it. Cos is root 3 by 2 when cos theta is 30 degree, so pi by 6. Okay. cot inverse root 3, you can rewrite this as tan inverse 1 by root 3. Okay, and tan inverse 1 by root 3 is pi by 6 also. Cos inverse negative 1 by root 2. Okay, negative we cannot directly take it outside. For cos inverse, what we have to do is do pi minus cos inverse of positive value 1 by root 2. So pi minus pi by 4, that's 3 pi by 4. Okay, I'll add one more value. Be very careful regarding this. Suppose cot inverse minus 1 is asked. Okay, you tell me which one is correct, which one is incorrect. Although if you have the idea of principal range, you can tell me. Suppose one student solves this like this, that cot inverse, it becomes tan inverse reciprocal of minus 1 is also minus 1, and the answer for this becomes negative can come outside, so answer is minus pi by 4. Another student solves like this, because cot inverse negative is there, so cot inverse, cos inverse and sec inverse, they all have to have answers in 0 to pi. For that, what do we have to do? We have to do the pi minus cot inverse of positive value. That means pi minus tan inverse, I can rewrite this as 1 upon 1, reciprocal of 1 is also 1. Okay, so that is pi minus pi by 4. That gives you 3 pi by 4. Now which one is correct? Of course, if you know that the range of cot inverse was 0 to pi, this has to be correct, but this has to be incorrect. So what is the problem? Why cannot we apply the reciprocal formula here? The problem with this formula is they are applicable only for positive values of x. For negative values, you have to be careful. Okay, see, for negative values, cosec inverse can work, but this cot inverse and tan inverse answer is 0 to minus pi by 2 to pi by 2, and this one has answer from 0 to pi. That's why it is problematic. So for this particular value, you have to be careful. What's your x? Is it positive or negative? Or I'll suggest is first deal with negative and then do the reciprocal. Okay, I dealt with the negative first, and that's why I got the correct answer with the second approach. Okay, but this could be the approach, this could be your thinking. So remember that, don't do reciprocal before, first deal with this negative and then do the reciprocal. It will be pretty safe then. All right, now we have dealt with most of the type of principal range. Okay. Now let's look at some properties. Okay, so principal range we have done, inverse trigo, properties. Now we'll talk about properties. Okay, let me get the properties. Few properties we have already discussed, so like this one, we have already discussed this. One second, something was wrong. Okay, that's the first property. We have already discussed these, but this time it is clearly mentioning what could be the possible values of x. Okay, and I told you one safe method to deal with the positive value with this conversion, that always take your negative sign in the first consideration and then deal with the inverse. see, for this one, it is defined that this formula is applicable only if x is greater than 0. These are the conditions that is mentioned. Okay, that for these values only it is defined. So my greater than 1, less than -1, basically for all values of x as such. For cosec inverse, if some value is there, we can do directly reciprocal, whether it's negative or positive. Same thing here, negative or positive, but this particular formula is applicable only if it is positive. So why even take risk with remembering that one formula works and one doesn't? Just deal with the negative first according to the principal range, and then do the reciprocal. Okay. Then negative, I told you that you can take negative outside. You can take negative outside. Okay, this is what I told you, that in sine inverse you can take negative outside, tan inverse you can take negative outside, cosec also you can take negative outside. Okay, I told you this because the principal range is -π/2 to π/2, means you can have negative answers. That's why this is the same thing. Okay, but for cosec, for cos, sec and cot, this is not applicable. So there we used to do pi minus pi minus. Okay. Again, it is written in terms of property. I have the tendency to teach it in a way so that you don't have to learn it as a property. Okay, because if you look at this, then you might get slightly intimidated that we have to learn everything. We have to learn this also. X belongs to -1 to 1, x belongs to R. No need to learn this. Just remember the basic idea. In sine, cos, tan inverse, you can take cosec inverse, you can take negative outside. For this cos, sec, cot, because the principal range is 0 to pi, so your answer will always be pi minus the positive value. See, this is negative. Here you have written positive, negative, positive, negative, positive. So you can change the negative to positive by writing pi minus. Okay. All right. Then one very important property, I'll say, this is something that you have to learn. This is basic. Okay. So the first proper property that we have to learn it is the fourth one, that sine inverse plus cos inverse x is always pi/2, tan inverse plus cot inverse x is always pi/2, sec inverse plus cosec inverse is always pi/2. This is true for x belongs to -1 to 1, because you have to give a proper value of x. Okay, because suppose you write sine inverse 2, not possible to solve. You cannot solve this. Okay, because the value inside the sine inverse has to be from -1 to 1, because sine is never 2. Okay, for no value of theta, sine is 2, because it is always ranging from -1 to 1. Sine is. Okay. Next property that you have to learn is this one, very important. This property, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Pretty much it looks like tan a plus b, is just that right now you are not adding tan, you are adding tan inverse. So x plus y upon 1 minus xy. With negative, you have to do the opposite. Tan inverse x minus tan inverse y becomes x minus y upon 1 plus xy. Okay. And 2 tan inverse x is tan inverse 2x upon 1 minus x square. Okay. You'll be using these properties a lot in the questions. Most of the questions will be done like this. We have the property for sine inverse x plus sine inverse y also, but I'll not recommend you to learn those. Use these, that will be better. Okay. All right. I think that's it. We'll start with the questions now. Okay. And I'll tell you some standard substitution type questions. First, let's deal with the kind of questions that uses this tan inverse, tan inverse. Let's get comfortable while applying this. Okay. Now that the property is done, let's look at some questions. All right, so this is our question. You have to prove that this is tan inverse this plus tan inverse this is coming tan inverse this expression. 2 by 11 tan inverse 7 by 24 is coming this. Okay, let's see. This is our tan inverse x, this is our tan inverse y. Let's solve the LHS. Although right now it is asking us to prove, they can give these two expressions and ask you, it gets simplified to, and they will give you 4 options: tan inverse 1, tan inverse 2, tan inverse 1 by root 2, sorry, tan inverse 1 by 2, tan inverse 1, like that. So let's solve LHS. So it becomes tan inverse x plus y upon 1 minus xy. Let's put down the values. Tan inverse x is 2 by 11 plus y is 7 by 24 upon 1 minus 2 by 11 into 7 by 24. Let's simplify. So tan inverse, you have to do 48. I'll take the LCM. 48 plus this becomes 77 upon, I'll not multiply this, I'll write like 11 into 24 upon denominator also. Okay, I have to basically 11 into 24 minus 2 into 7 upon 11 into 24. 11 into 24 we have to do. This cancels. Okay, so effectively that becomes tan inverse, this becomes 5, 7 for 11, 115 upon this 24 into 11 becomes 262 minus 14. 14, 24 to 48, 77, 85, 15, and this is correct. Okay, 1 second. Sorry, 7 for 11, 12, 125 no? So 262 minus this one becomes 260, not 2, this is 264. This one is also incorrect. 24, 24, 264. So that becomes tan inverse 125 by 250. That's it, solved. 1 by 2. So yes, we have proved it, tan inverse 1 by 2. That's your RHS. So right now I know the questions are of 2 proving, but we'll have to see accordingly that how to apply these properties. I'll give you one more question with this idea. Tan inverse, tan inverse. Okay. This one, 2 tan inverse something something like this. Now this time we cannot add this tan inverse with this tan inverse. Reason is this 2 present outside won't allow it, because the property is tan inverse x plus tan inverse y. So what we do? First we have to simplify 2 tan inverse x. The property goes like this: 2 tan inverse, this is x. So 2 tan inverse x is tan inverse 2x upon 1 minus x square. Okay, so let's use this property. So tan inverse 2 into 1 by 2 upon 1 minus 1 by 2 whole square, plus let's keep tan inverse 1 by 7 as it is, then simplify. This becomes tan inverse, this becomes 1 upon 1 minus 1 by 4, that becomes 3 by 4. So 4 will come here. Tan inverse 1 by 7. Now you apply tan inverse x plus tan inverse y. So tan inverse x plus y, add them, 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. Solve this. Let's solve it here. So tan inverse, that becomes 28 plus 3 upon 21. Denominator also becomes 21 LCM. 21 minus 4. So tan inverse 31 by 21 upon, we don't even have to write 21. Let's cancel denominator with denominator. So tan inverse 31 by 17. That's your RHS. So anyway, we got it. All right, this is done, this is done. Now let's look at the questions of to prove with substitution being involved. And for substitution as such, there is no one trick to solve a question. It's just that there is a pattern for substitution that you have to understand. So what I'll do is I'll create a table and we'll keep on adding the formula of substitutions. I'll tell you what do I mean by that. And remember that this chapter is very much correlated with Trigo, so go through all formulas of Trigo. I literally mean all formulas because everything will be used here. Let's look at this question. I have to create a table for substitution also. Okay. Substitution. Okay, so if you look at this expression 3x minus 4x cube, if you ever get this kind of expression, you have to put x as sine theta. If it is reversed, 4x cube minus 3x, you have to use x as cos theta. Now let's see how it helps. Actually, I'll take both the questions together. For these questions, right now I'll say just focus on the question. This part, it defines the domain. Okay. So right now it's just making the expression valid. He's saying that with these values of x, the expression never becomes invalid. Okay. Let's look at this question. So I gave the substitution for this as x as sine theta. And for this expression, I gave substitution as x as cos theta. Let's see what happens. I'm solving the RHS. Okay, but they will give you, they'll ask that this expression simplifies to. Okay, they'll not give this expression. Similarly here also, they'll not give this expression. They'll say this expression simplifies to, and then you have to judge. Okay. So let's see, RHS becomes sine inverse inside the bracket. This is 3x, that means 3 sine theta minus 4 sine cube theta. The moment you see this, you have to recall one property, that this is what? This is sine inverse, this is sine 3 theta, the formula for sine 3 theta or sine 3a. Okay. Now what happens is that the inverse function cancels the sine. Okay, because you will calculate the value of it's like this, sine inverse of sine 1 by 2. Okay, sorry, my bad, sine inverse of sine, let's say 30 degree or pi by 6. So sine inverse, sine 30 is 1 by 2. What is sine inverse 1 by 2? Again 30 degree. So if you look at these steps, pretty much it's like they are cancelling each other. So sine inverse cancels sine, cos inverse cancel cos, tan inverse cancels tan. Okay, so they two cancel each other. So answer is here 3 theta, but we were solving for x. So if x is sine theta, what is theta? Theta is, take sine on the other side, it becomes sine inverse x. So this becomes 3 sine inverse x. Okay. Now look at this one. This one again, it has the same idea. Let's solve the RHS. again it will become one property. So cos inverse 4x cube means 4 cos cube theta minus 3 cos theta. Okay, so that becomes cos inverse, this becomes cos 3 theta. Again cos inverse cos cancel each other, you get 3 theta, that's 3 cos inverse x. Okay, how do we get cos inverse? If x is cos theta, we can write theta as cos inverse x. Put it here, put it here. So these are the questions that cannot be solved directly. You have to put x as some sine, cos, tan. Okay, and you have to learn these substitutions. Okay, by looking at the expression, you'll practice, and then you might be able to just see the expression and tell which is this, but somehow you have to learn this. Okay, all right, let's look at another question. I'm taking two questions now again. Look at these two questions. So tan inverse square root of 1 plus x square. One time it is 1 plus x square, one time it is x square minus 1. Okay. So you can generate the substitution also. It's just that you have to think, what can I put as x so that 1 plus x square root simplifies. And so you have to recall something from trigo. See, 1 plus tan square theta is cot, sorry, not cot. 1 plus tan square theta is sec square theta. You can use this as x. Means if x was tan theta, this could have been solved. Similarly with x square minus 1, just take this one on the other side. Sec square theta minus 1 is tan square. Means if x was sec theta for this expression, this can be simplified. Okay. Now let me just put it in the table. If you have square root of 1 plus x square, x is tan theta. Sometimes you can have a variation. I'll talk about the variation also. 1 x square minus 1. Then you have sec theta. Sec square theta minus 1 is tan square. Okay. Another, the variation comes like this. Instead of 1 plus x square, you can have a square plus x square. So you just replace x as a tan theta. Okay, so that a gets common, and you can still apply 1 plus tan square property. Similarly here also, if you have suppose x square minus a square, you put the substitution as a sec theta. Okay, so pretty much same idea. It's just that if a is there, some number is there, so you use a tan theta, a sec theta. Let's see the question now. Fifth one, x is tan theta. So the question becomes, okay, so this time we don't know how, what will it become. Let's see. Tan inverse 1 plus tan square x square root minus 1 upon x is tan theta. Okay, so this becomes tan inverse. What is 1 plus tan square? Sec square. Sec square into square root will be sec theta. So sec theta minus 1 upon tan theta. Now again it has become a question of trigo. So inverse trigo, there is no direct question of inverse trigo too much. Again you have to deal with trigo only. So tan inverse sec theta, you do the reciprocal, convert this in sine and cos. So it will become 1 minus cos theta upon cos. Denominator will become sine theta by cos theta. So I'll just write cos will cancel. That becomes cos theta. Sorry, sine theta. So it becomes tan inverse 1 minus cos theta is, now you have to use the again property of trigo. What is 1 minus cos theta? 2 sine square theta by 2. Okay, half angle properties. I told you that this particular 1 minus cos 1 plus cos is very important. See? And sine theta, if I'm breaking 1 minus cos theta in half, 2 sine square theta by 2, I have to break sine theta also in half, so that becomes 2 sine theta by 2 cos theta by 2. Go through the properties that I discussed in the trigo, otherwise you'll struggle with this chapter while understanding it. So the recommendation is, before even starting this chapter, go through all the properties, get it in one single place, keep the formula sheet with you while solving this for the starting. This becomes 2 sine theta by 2 cos theta by 2. Okay, so sine theta cancels 1 sine, 2 cancels. Interestingly, it becomes tan inverse tan theta by 2, and again inverse and the function can cancel each other. That becomes theta by 2. Now what was our theta? If x is tan theta, that means theta is tan inverse x. So I can replace this theta with tan inverse x upon 2. That's the answer. Okay. All right. Let's look at one more. Tan inverse square root of x square minus 1. Sixth one. Tan inverse 1 upon x square minus 1. Okay. Let's look at this. I told you to use x as sec theta. Let's use tan inverse 1 upon square root sec square theta minus 1. Sec square theta minus 1 is tan theta. So sorry, tan square theta. So it will cancel the square root. So it will become tan theta. What is 1 upon tan theta? It becomes cot theta. Now you cannot cancel tan inverse with cot. We somehow, either this becomes tan or this becomes cot inverse. Okay. So what I'll do is, I'll use the property that I told you to learn this. Okay. Where is the property? This property has this benefit that this can be modified to convert tan to cot inverse or cot inverse to tan inverse. What can I write? That pi by 2 minus tan inverse x is cot inverse x. Okay. So, or I can rewrite this as that if I want tan inverse to get converted to cot inverse, so I can write tan inverse x is equal to pi by 2 minus cot inverse. Similarly, this one, if suppose I ask you to convert sine inverse to cos inverse, you write down sine inverse as pi by 2 minus cos inverse. You can write other way also, cos inverse also is pi by 2 minus. So you have to do pi by 2 minus to interchange sine and cos, tan sine inverse cos inverse, tan inverse cot inverse, cosec inverse and sec inverse accordingly. So that's the application of that property. So I can write tan inverse x as pi by 2 minus cot inverse x. Let's write down. So pi by 2 minus cot inverse. This complete thing is our x because it's inside cot. Sorry, inside tan inverse. So cot inverse cot theta. Now we can cancel. So answer is pi by 2 minus theta. Okay. So pi by 2 theta was tan inverse x. Again, pi by 2 minus tan inverse x can be rewritten as cot inverse x. So whenever you do pi by 2 minus, you change tan to cot, tan inverse to cot inverse, sine inverse to cos inverse, sec inverse to cosec inverse. Okay, that's the final answer. All right. Okay. Let's look at one more important question. This time I think it's easy because substitution is directly given. Means you don't have to substitute because inverse already includes trigo. We have to solve this. If only here x was there, Okay, x and x. Then we have to think that what can we replace x so that some property is applied and it becomes simple. Okay, right now it's already there, so let's use it. Again, the property. What is 1 minus cos? What is 1 plus cos? 1 minus cos is 2 sine square half of the angle. This is 2 cos square half of the angle. I think after that it becomes very simple. If you know the trigo, inverse is also simple. Square root of 2 sine square x by 2 cos square x by 2. 2 cancel. Sine by cos is tan square, that will cancel square root, so that becomes tan inverse tan x by 2. Okay, square will cancel square root, and this is complete square root. So tan inverse and tan will cancel, so answer is only x by 2. Okay, simple enough. Next, let's deal with this. A square minus x square. So I'll again add the substitution idea here. Suppose you have square root of 1 minus x square. You can write x as sine theta as well as cos theta. Okay, your call. Same thing. If you have, instead of 1, you have a square minus x square, write down x as a sine theta or a cos theta. Okay, let's use it here. X is equal to a let's use sine theta. Okay, I know you have the tendency to use sine first before cos, so let's use that. In case someone wants to try it with cos, you can try, same thing will happen. Okay, so tan inverse a sine theta upon square root of a square minus x square is a square sine square theta. So tan inverse a sine theta upon square root of a square 1 minus sine square theta. So that becomes tan inverse a sine theta upon a square in the square root cos square theta. 1 minus sine square is cos square. That becomes tan inverse a sine theta upon a cos theta. A cancels. Okay, that becomes tan inverse tan theta. These two cancel out. Theta is the final answer. So what's our theta? So if x is a sine theta, x upon a is sine theta, theta is sine inverse x by a. Okay, so answer is sine inverse x by a for this question. Okay, all right. Okay, one of this is like one particular type of a question, unique in itself. Okay, the expression first of all is very weird. Okay, 90% of questions are done by cos, few are done with sine or cos, and very few are done with sec. Majoritively tan is the great substitution for all. This one also involves tan. Now I'll not recommend you to learn it as such. It's just that you have to see, this is a very weird expression. Okay, let's just put x as a sine theta. Okay, x as a, sorry, not sine theta, tan theta. Let's see, tan inverse 3a square into a tan theta minus tan minus a cube tan cube theta upon a cube minus 3a into a square tan square theta. Okay. This complete expression is inside tan inverse. Tan inverse, numerator you will get a cube common, 3 tan theta minus tan cube theta. Denominator you get a cube common, 1 minus 3 tan square theta. Okay. A cube cancels. This becomes tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is the property of tan 3 theta. So I told you, like, this question is unique in itself, okay, because this kind of expression is only one, tan 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. You have to know this property. Again, very specific to this property only, no variations, nothing. Tan 3 theta, again tan inverse tan cancels, 3 theta, and what's our theta? Same thing, x by a is tan theta, theta is tan inverse x by a. So 3 tan inverse x by a. Okay, all right. Okay, I'll add this in the table, but don't worry about this too much. It's not a standard kind of substitution. Okay, 3a square x minus x cube upon 1 minus 3a x. X is a tan theta. Okay, so don't worry about this too much. You'll know. If you have done this question now, if you see this in the exam, you'll know that this was the weirdest identity of tan 3 theta. The expression itself is very weird. Okay, learn these, the top 3 that I have discussed. Learn these, or any upcoming concept that will do. Okay, fine. We'll continue with this topic in the next class. Okay, so that's it for this session. Okay, see you in the next class. Good day.